Everyone, today I will be discussing with you another topic in ME review. This time we will talk about trigonometry. At the end of this lesson, you should be able to recall the fundamental concepts and principles in trigonometry, list important formulas and equations in trigonometry, and apply these concepts, principles, the formula and equations in solving worded problems in trigonometry. This will be the outline of my presentation. Let us start first with the angles and its measure. The units in measuring angles are shown here in the presentation. 1 revolution is equivalent to 360 degrees, 2 pi radians, 400 grads, 400 gons, and 6,400 mils. So, if you want to convert one unit to another, all you have to do is to use these conversion factors. There are names given to angles and its equivalent. Say for example, for acute angle, if it is between 0 degrees and 90 degrees. It is right angle when the angle is 90 degrees exactly, obtuse angle between 90 degrees and 180 degrees, and straight angle if it is equals to 360 degrees. The sum of angles can be 2. We have complementary and supplementary angles. The angles are complementary if their sum is 90 degrees. On the other hand, the angles are supplementary if their sum is 180 degrees. Now that we know the angles and its measure, let's move forward to triangles. The different classifications of triangles are shown here. We have equiangular for all angles are congruent, acute angle for all angles are acute, right angle if one angle is right, obtuse triangle if one angle is obtuse, equilateral if all sides are congruent, isosceles if at least two sides are congruent, and scalene if there is no sides that are congruent. The Schwarz inequality states that the sum of any two sides of any triangle is greater than the third side. This inequality is helpful to determine whether a given line can produce a triangle. So, for a triangle to be possible, it should be that the sum of any two sides should be greater than the third side. The intersection on triangles are as follows. We have centroid, which is the intersection of the medians, orthocenter, which is the intersection of the altitudes, incenter, which is the intersection of the angle bisector, circumcenter, which is the intersection of the perpendicular bisector. To know them better, I have here some illustration for the incenter, the centroid, the circumcenter, and the orthocenter. Let's move forward to right triangles. Right triangles can be solved using Pythagorean theorem. Say for example, you are looking for the hypotenuse, then you can use the relationship c squared is equals to a squared plus b squared in order to get the hypotenuse. Again, it is only applicable to right triangle. The six trigonometric functions are also helpful in finding the different sides or angles in a triangle. We have the sine, cosine, tangent, cosecant, secant, and cotangent. The signs of the trigonometric function in each quadrant is shown here in the presentation. Say for example, for sine and cosecant, we can see that they are positive in the first and the second quadrant, and negative in the third and the fourth quadrant. The other signs are shown also for cosecant, secant, tangent, and cotangent. Let's move forward to trigonometric identities. Here are the different trigonometric identities. They are helpful in solving, for example, the angles and also the equations, the roots of the trigonometric functions. We have the Pythagorean identities, We have the tangent and cotangent identities, reciprocal identities. We also have the half angle formula and their alternate form and the double angle formula. We also have the sum and difference formula and the product to sum formula. So when you are solving, for example, the roots of a trigonometric function, then you may also stumble with any of this helpful formula for you to be able to simplify the given function. Let's proceed to oblique triangles. Oblique triangles can be solved using law of sines and cosines. Take note that we cannot use the Pythagorean theorem when the triangle is an oblique triangle. So, another way to solve them is using the law of sines. So you can see here the formula for the law of sine. We also have the law of cosines in order to solve the different sides given the different angles and length. The Heron's formula, on the other hand, is useful in solving for the area of a triangle that is oblique. Let's have some sample problems. Sample problem number 1. How many gradients is 1.5 revolutions clockwise? So from the units and measuring angles, we know that 1 revolution is 400 grads. Then, for 1.5 revolution, we would multiply it with a conversion factor 400 grads per 1 revolution, so that the answer would be negative 600 grad. Take note that the negative sign means counterclockwise. Counterclockwise is the positive value. Simple problem number 2. The angle has its complement 3 times its supplement. Find the angle. The complement of angle A, say for example, A is the unknown angle, is 90 minus A. The supplement on the other hand of angle A is 180 minus A. Since the complement is 3 times its supplement, then we can express the relationship between them as 90 minus A is equal to 3 times 180 minus A. So from that, we can solve the angle A, and that is 225 degrees. Sample problem number 3. If the hypotenuse of a triangle is 100 cm and one side is 10 cm longer than the other side, what is the length of the shorter leg? Using the Pythagorean theorem, we know that a squared plus b squared is equal to c squared, where a and b are the legs, c is the hypotenuse. Since the other leg is 10 cm longer than the other, then we can express b as a plus 10. On the other hand, since the hypotenuse is 100 cm, then we can also substitute that. And if you're going to look at it, we already have the unknown, which is a, and that is 65.53 cm. Therefore, the length of the shorter leg is 65.53 cm, and the longer leg is 10 cm longer than that shorter leg, or that is 75.53 cm. In which quadrant that A terminates if secant is positive and cosecant is negative? Using the table, sec is positive in the first and the fourth quadrant. Also, cosecant is negative in the third and the fourth quadrant. So if you're going to look at it, we can get a positive secant and a negative cosecant in quadrant 4. So the answer is quadrant 4. Sample problem number 5. Solve for x if tan 3x is equals to 5 tan x. Say for example, you are taking the board exam and then you are given with the choices. You can actually do a reverse engineering for this type of problem. So the good thing about trigonometry, especially when dealing with trigonometric identities, the reason why you don't have to memorize all of those formula is that you can do a reverse engineering. So what you're going to do is you substitute all of this value of x here in the given and see which of these values will satisfy the given equation. Say for example 20.7 degrees. So if you substitute that here in tan 3x and at the same time substitute x here in 5 tan x, you would see that it would satisfy this equation. So the answer is actually 20.7 degrees. However, if you want to really solve it, then you can use the trigonometric identities. We know that tan 3x is equals to 3 tan x minus tan cube x over 1 minus 3 tan squared x. And that is equals to 5 tan x based on the given. So we're going to simplify that by distributing the 1 minus 3 tan squared x in both sides. And then we're going to simplify it further until we can have a this one. Then finally, we can solve for the value of x. So the value of x would be 20.7 degrees. So if you can see, if you're going to use this method, it would take time. And at the same time, it would take a lot of memorization in order to come up with the right identities. So the best way to solve such kind of problem is using reverse engineering. So use the choices to get the correct answer. If tan x is equals to 1/2 and tan y is equals to 1/3, what is the value of tan x plus y? So what you're going to do is just to substitute the value. Say for example, since you have tan x equals to 1/2, then x is 26.565 degrees if you're going to get the arc tan of 1/2. Tan y is 1/3, therefore y is 18.44 degrees. Substituting these values in tan x plus y, then we can get 1. So the correct answer is 1. Sample problem number 7. A PLDT tower and a monument stand on a level plane. The angles of depression of the top and bottom of the monument viewed from the top of the PLDT towers are 13 degrees and 35 degrees respectively. The height of the tower is 50 meter. Find the height of the monument. So we are given here again with the height of the tower 50 meter and the monument which is unknown. When we are looking for that, and we designate the value as h. We're also given that the angle of depression of the top and the bottom is 13 degrees and 35 degrees. So when the angle of depression, it is the angle viewed from the horizontal of your eye downwards. So from the top of the tower, that would be this angle here, 13 degrees for the top and then 35 degrees for the bottom of the monument. So what we're going to do is we're to solve the value of h. So if you're going to look at the triangles that you can form here, for 13 degrees, focusing your attention here in this triangle, in this portion. So you can find that your tan of 13 degrees is equals to opposite, which is 50 minus h, over the adjacent, which is equals also to d, since this one is also equals to d. Anyway, we get 50 minus h because we know that this height here is 50 meter. And then since this one is h, then the remaining would be 50 minus h. So that's why we have this one for the first equation. So from that, we can solve for the value of d in terms of h. Then, we're going to get another equation that we can use in order to get the value of h. So if you're going to look at it again, we can have another triangle which is the 35 degrees. This one. So if you're going to use a triangle, you know that tan of 35 would be 50 meters, since this is the opposite. It's 50 meter over the adjacent, which is d. Then solving for d again, then you can get equation 2. Now that you have two equations in terms of d, you can equate them. And then if you're going to look at it, the only unknown would be the value of h. Solving for the value of h using shift solve in your calculator, that would be 33.51 meter. So it's really helpful to use shift solve, especially in board exams, because you are no longer required to show your solution. Anyway, so you just have to use shift solve. So the answer here is 33.51 meter. And if you're going to look at it, it should be less than 50 meter, obviously, because it's less than the height of the PLDT tower, and that is also correct here. The angle or inclination of a road having 8.25 degrees percent grade is blank degrees. So for the angle of inclination and grade, they are related by the tan. So such that tan is equals to the decimal value of the angle or inclination of the road. So that is 8.25% or 0.0825. Solving for A, the degrees is 4.72. If the sides of the parallelogram and an included angle are 6 meter, 10 meter, and 100 degrees respectively, find the length of the shorter diagonal. So we're looking for the length of the shorter diagonal. So this is how it would look like based on the given. So we have here the 10 meter, we have 6 cm. The included is 100. So basically, since the total should be 360 degrees, then we can, and this is a parallelogram, then the opposite angle would be the same. Using cosine law, you can see that our d squared, the diagonal that we are looking for, is equal to 10 squared plus 6 squared minus 2 times the product of 10 meter and 6 cosine of 80. So this is based on this triangle here. So we have the included angle, which is 80, and including the sides that includes it are 10 cm, 10 meter and 6 meter. Solving for d, that would be equal to 10.73. So the length of the shorter diagonal is 10.73. So we know that this is the shorter diagonal because the angle here is shorter. Because if you're going to select this diagonal, that would be longer because the angle here again is longer. So that's how you should also take note for a parallelogram. So, in summary, we were able to discuss the different basic fundamental topics in trigonometry, the angles and its measure, triangles, right triangles, trigonometric identities, oblique triangles, and also some sample problems to guide you in this topic. See you in a synchronous meeting.